On this video, I am going to discuss informal logic. So at the end of the lesson, you are expected to define logic and argument, differentiate deductive and inductive reasoning, and create geometric conjectures based on inductive reasoning. So let us define first logic. Logic is a science that studies the principle of correct reasoning. It is a science because it is a systematized body of logical truths and principles governing correct thinking. So they said also that it is a science that evaluates arguments. So when you say logic, it has two reasonings. It may be deductive or inductive. So let's go back to arguments. Yan. Argument is a group of statements including one or more premises or statements and one and only conclusions. So premises, compose ito ng statements. Okay. Let us define first deductive reasoning. It is a basic form of valid reasoning, or deductive reasoning is also known as formal logic. Yan. Starts out with general statement or hypothesis and examines the possibilities to reach specific logical conclusion. So there are two laws of deductive reasoning. First is the law of detachment. So if the given statement is true, ayan, statement, and let us say P is true, then Q is true. Example, let us say planets in our solar system revolve around the sun. The planet Uranus belongs to our solar system. Therefore, Uranus revolves around the sun. And another example, the square of any real number is non-negative. The number negative 6 is a real number. Therefore, the square of negative 6 is non-negative. Then another law of deductive reasoning is we have the law of syllogism. So we have two statements here. So if P, Q, and QR are true statements, then P to R is true statement. Example. So let us define first. In deductive reasoning, if something is true of a class of things in general, it is also true for all members of that class. Example, all men are mortal. Arnold is a man. Therefore, Arnold is mortal. Yan. Since all men are mortal and Arnold is a man, are assumed true. Therefore, the conclusion Arnold is mortal is also true. So let us have the inductive reasoning. It makes broad generalization from specific observations. So inductive reasoning also, it is being called as informal logic. Inductive reasoning is noticing a pattern and making an educated guess based on that pattern. Even if all the premises are true in a statement, inductive reasoning allows for the conclusion to be false. Let us have an example. Dante is a grandfather. Then Dante is a bald. Therefore, all grandfathers are bald. The question is it true statement or is the reasoning true or the reasoning false? It is false. Okay. The conclusion follow logically from the statement. It is not following logically from the statement. So that is the inductive reasoning. So you are judging general on its class, or you are going to judge something by using its part. Okay, let us use inductive reasoning. We have angle 1 and angle 2. So angle 1 and angle 2 are complementary angles. Then angle 1 and angle 3 are also complementary angles. Therefore, angle 2 and angle 3 are equal measures. Is our conclusion here valid? You may pause the video, think if it is valid. Okay, the answer of this is yes, it is valid. We all know that complementary angles, uh, you are adding two angles that will make 90 degrees. So since angle 1 is obviously congruent to angle 1, so in other words, what will be the measurement of angle 2 will not change. The same with the measurement of angle 3 will not change since angle 1 is congruent to angle 1. Therefore, I can say that angle 2 is congruent to angle 3. So they are equal in measures. We have another example. Given x, y, and z, they lie on the same line segment. The conjecture or the conclusion is y is between x and z. Is the conjecture valid? Okay, the conjecture is not valid. Okay, according to the condition, they lie on the same segment. So it may be y or point y is the first point before point x. Then maybe also point z is the first point before point y. So since the condition given here is only they lie on the same line segment, therefore mm, the conjecture is not valid. Okay? Based on the discussion, how do you differentiate inductive from deductive reasoning? You may think of it. Okay, I want also to have this example. Every square of odd number is odd. P is an odd number. Therefore, the square of P is an odd number. I leave it to you. That would be your assignment. Okay. Take time to practice using this statement or using this reasoning. Okay, another question, is the conclusion valid? Practice using this statement. Okay, practice on this also. Determine if the conjecture is true or false based on the given information. Okay, if possible, give the counterexample. And if it is false, so you are going to give, if your answer is false, then give the reasoning why it is false. Okay, so given we have line AB or line segment AB equals to line segment CA. Conjecture is A is the midpoint of BA. So kindly determine if the conjecture is true or false. So I want to add also the conditional statement. Yan. So conditional statement, we have the hypothesis and the conclusion. So hypothesis is part after the word if, then conclusion is part after the word then. So yan. To represent if then statement symbolically, we use the basic form below like this. Yan. If P, then Q. So P is the hypothesis, then Q is the conclusion. So let us rewrite this statement into if-then form. So vertical angles are congruent. So how are we going to rewrite this in if-then form? So we can show in this way, if there are two vertical angles, then they are congruent. Or maybe in this way, if two angles are vertical, then they are congruent. We have also the counterexample. Yan. It is used to show a conditional statement is false. So just like the example previously or previous example, if your conclusion or conjecture is false, you may present the counterexample or illustrate the counterexample. So it must keep the hypothesis true, but the conclusion false. So find the counterexample to prove the statement is false. So let us say, if x squared is 81, then x must equal to 9. So the conclusion is x squared equals 81. Okay? Then x must equal to 9. Let us say 9 squared is 81, right? So this is correct. However, I can give a counterexample in order to say that this statement is false. How I am going to show it? So I am going to find another number that if I am going to square, the result is still 81. So my counterexample is x could be negative 9 because negative 9 squared is 81. But x is not equal to 9. So I gave already the counterexample that not all the time the value of x is 9. I can change also the value of x into negative 9. Find a counterexample on this one. If a line lies in a vertical plane, then the line is vertical. Okay? So you may use illustration to give the counterexample, just like this one. Okay? So, yan. It makes the hypothesis true and the conclusion false. So, yan. A line lies in a vertical plane, then the line is vertical. And this is my counter example. Okay? Okay. If I am going to say, if x squared equals 49, then x equals 7. Counter example, x equals negative 7. Okay? So, other forms of conditional statement. So, not only if, then. So, we have another form. We have the implies. Yan. If P, then Q. You may use P implies Q. Then you may use also P only if Q. Then Q if P. Yan. So, these all say the same thing. Yan. Okay. So, let's proceed to negation. Okay. Negation. The negative of the statement. Example, write the negative of the statement. Angle A is acute. So, I'm just simply write angle A is not acute. So, I am going to use this symbol. This symbol. So, it represents not P. So, it represents the negation of P. So, writing the opposite of the statement or the antonym of the statement. So, for example, negate x equals 3. So, x equals to 3, so I am going to say x not equal to 3, or if I am going to write that mathematically, I'm just going to put slash in equal or the not equal sign. Okay, so x equals 3. If I am going to negate that one, that would become x is not equal to 3. So negate t greater than 5. You can pause the video and practice or answer the negation of t greater than 5. Okay? The answer of that is t is less than or equal to 5. So that is the negation of t greater than 5. T is less than or equal to 5. Converse. Okay? So you are going to switch the hypothesis and conclusion parts of the conditional statement. So that is the converse of the um, conditional statements. So write the converse if or of if you are brunette, then you have brown hair. So just simply switch the hypothesis and conclusion. So it will become now if you have brown hair, then you are a brunette. So that is the converse of conditional statement. Just remember switching the P and Q. Okay, again, converse is a new statement that switches the hypothesis and conclusion of the original statement. Okay, so let us write the converse of the following conditional statement. If Nemo is a fish, then he swims. Okay, so yan. The answer of this one, if Nemo is a fish, then he swims. So the answer of that is if Nemo swims, then he is a fish. So let us state whether the condition is true or false. If false, find a counterexample. Yan. If you live in San Francisco, then you live in California. The answer is true. Of course, San Francisco is part of the California. What if I am going to get the converse of that? I am going to say if you live in California, then you live in San Francisco. Is that also true? That is false. Because not all the time, if you live in California, you live in San Francisco. It is just like the same. If you live in Davao City, then you live in Philippines. That statement is true. However, if I am going to say if you live in the Philippines, then you live in Davao City. So that is false because not all the people that lives in Philippines or not all person that lives in the Philippines also lives in Davao City. So the counterexample is this one. You may change the place. So if you live in California, so you may change California by Denville, Alama, Livermore. So for example, the statement that we use, so you can um, use Digo City, Cebu City, Manila City, Quezon City. Just like that. So just make the hypothesis true and make the conclusion false. So let us have here another example. Statement, if points are coplanar, then they are collinear. That is false. So how are we going to give the counterexample of that? So you may show using illustration. Okay. So I'm just going to put the points inside the plane not aligned in order for them not to be collinear. So it makes the hypothesis true and conclusion false. Okay, converse, if points are collinear, then they are coplanar. Yes, that is true. So if they are on the same line, if the points lie on the same line, then obviously they will lie on the same plane. Okay, if line segment AB is congruent to line segment BC, then B is the midpoint of AC. The answer is false. Yan. Because I can make this one. I can place B or point B first before point A, or I can place point C first before point B, or point C before point A. So I can give the counterexample of that. Okay. So if B is midpoint of AC, then AB is congruent to BC. That is true. Yan. So I already give the midpoint, which is point B, on the line segment AC. So therefore, line or AB or segment AB is congruent to segment BC, because midpoint, I divide them into two equal measurements. Yan. Another question based on the discussion: is there an interchanging hypothesis and conclusion? Okay, you may answer this one. You may pause the video in order for you to practice the topic. So let's proceed to inverse. Okay, inverse is negate the hypothesis and conclusion of conditional statement. So write the inverse of if you are a brunette, then you have brown hair. Simply, if you are not brunette, then you do not have brown hair. So I simply write the negation of P, then the negation of Q. So you are a brunette, so I negate that as you are not a brunette. Then you have a brown hair, then the negation of that, you do not have brown hair. So contrapositive is negate, then switch the hypothesis and conclusion. So this is the combination of the inverse and converse. So same example, write the contrapositive of if you are a brunette, then you have brown hair. So negate first, if you are not a brunette, then you don't have brown hair. Then switch the hypothesis and conclusion. So it will become, if you do not have brown hair, then you are not a brunette. So the original conditional statement and its contrapositive will always have the same meaning. So the converse and inverse of conditional statement will always have the same meaning. Take note of this. Contrapositive and the original conditional statement, the same lang yung meaning nila. At the same time, converse and inverse, they are implying the same meaning. So, yan. So this is the summarization of their concept. So you may pause this one in order for you to see the summarized concept of converse, inverse, and contrapositive. Okay, so let us have an example. Write the inverse, converse, and contrapositive of this statement. Okay, so the original statement is if two angles are vertical, then the angles are congruent. You may pause the video para makapag-practice ka to write the inverse of this statement the converse of this statement, and the contrapositive of this statement. Okay? The inverse of this is if two angles are not vertical, then they are not congruent. Okay? The converse is if two angles are congruent, then they are vertical. So inverse, I negate the conclusion and the hypothesis. Then in converse, I switch the conclusion and hypothesis. Then in contrapositive, I negate them, then switch the conclusion and hypothesis. So if two angles are not congruent, then they are not vertical. Okay, so you may practice this one. So write the conditional statement. Okay, we have two premises given here, P and Q. So P, two lines are perpendicular. Q are their slopes are negative reciprocals. So what are you going to do? Write the conditional statement. Then after you write the conditional statement, write the converse. Then after you write the converse, write the inverse. Then after you write the inverse, write the contrapositive. You may pause the video in order for you na makapag-practice sa given. Okay? Then also, we have here the symbolism of the statement. Yan. You can fill the table here. You can give statement, then you can identify if it is true or false. Hopefully, you learned something.